Everyone. So let us now move to the next talk for this track. And this one is on scaling private LLM model services with KServe and Modelcar OCI. And this is being presented by Mayuresh Krishna, who is the CTO and co-founder at Initialize.ai. So Mayuresh, the stage is all yours.
Okay? Yeah, I'm good. So yeah, thank you for joining, and thank you for being here for my talk. So I'll talk a little bit about how KServe and what KServe does in helping in inferencing for whether it's large language models or any kind of models, and we'll kind of dive into a little bit of like how we can use Modelcar OCI to make it much more efficient. To get started, a quick background about me. My name is Mayuresh Krishna. I go by MK to make it easy for everyone to remember me. I'm co-founder of Initialize, ex-VMware, ex-Pivotal, and you can find me on Twitter at Mayuresh Krishna. I couldn't get MK. I guess if I would have gone on Twitter in 2009, 2008, I might have gotten an MK handle, but I couldn't get it later on. Just quickly, the overview of the talk. We are going to talk about model serving in general. What are the challenges, or what does model serving entails? We'll look at what KServe is and how KServe helps in the whole inferencing area of model serving. And then we'll look at KServe LLM runtime to look at how KServe helps in large language model runtime serving. And then we'll get into the Modelcar OCI to just kind of understand what is Modelcar OCI and how it can help. And then we'll get into a bit of Q&A after that. In this whole talk, after we get into the KServe LLM runtime, I'll do a little bit of a demo of how that works with KServe. And then I'll kind of try to show a difference between when you run out-of-the-box LLM runtime versus you run Modelcar OCI, what is the difference? So just to kind of set the stage on model serving is an integral part of the machine learning lifecycle overall. If you think of it, a lot of AI and data science engineering is spent, or time is spent on the training side of the world, where you're training your models, you're fine-tuning your models, and the data engineers are generally not very apt at like how do you run it at scale, right? It works on my laptop. I'm able to train my model, fine-tune it. I can spin up my fast API and use it, but now how do I get it to production and I scale it in production? And that's where the model serving comes into play in the whole life cycle. And if you think of it, the whole idea of model serving, and then when you delve into ML infrastructure, it's complex. And we are talking about an era where almost every month, new large language model versions are coming out from different organizations. And if you are fine-tuning based on some of those, the base large language models, and if it takes you like 3 months, 6 months to deploy your fine-tuned model, you're already behind the curve, right? So, and that's why this I put it out there, like 1 hour here is about 7 years in Earth. So 1 month not able to deploy your application or model inference in production is almost losing out to your base large language model has now moved on, and you have a newer ones, and you have to go back and fine-tune it. So it is important to kind of simplify how do you serve your models in production. So some of the things which gets into the consideration of deploying large language models or any models as such for inferencing. The concept of deploying model as a microservice is a common strategy which is kind of played out, which is being used. And essentially, the idea is that similar to an application where you deploy as a microservice and then consume it, you can deploy your models as a microservice and then inference it. Most of the models which you're deploying for inferencing, you'll have some sort of an API or a REST or a gRPC endpoint, or otherwise kind of exposing that so that applications can consume it and use that inferencing data for any kind of whatever business use case you have on top of that model. But there are considerations which you have to take into when you are deploying these models and inferencing it. Like, how do you containerize these models? Like, is containerizing and deploying on Kubernetes is a good way to do that. And one of the things which kind of helps in doing that is because the infra teams are very well versed with, at this point, deploying applications with containers and Kubernetes. Can we extend that whole construct and standardization on deploying your models and using that? And for them, when you do that, how do you containerize those models? Are the inference response times as containers good enough for serving your models and serving your predictions and inferencing to your applications? And then in the data science area, there are different types of runtimes for model. There are different types of model serving runtimes. How do you make sure that you're able to support that on Kubernetes when you're trying to deploy those model inferencing? Like, for example, some data science engineers would use TensorFlow, some would use PyTorch, some would use Onyx runtime. So there's different runtimes which you could be using, or data science engineers would be using to build their models. And now when you want to inference it, how does infrastructure team or platform engineering team make sure that they're able to provide support across the board for these different types of models coming in from the data science team? So that's where essentially KServe comes into play. It's essentially, it's supposed to be a one-stop solution for any kind of model runtimes you want to inference on top of Kubernetes. So if you think of it as Kubernetes was built to be kind of a generic engine to enable you to build application platforms on top of that, or if KServe is kind of something similar to that from model inferencing perspective. It is built as a generic kind of construct on top of Kubernetes, on top of which you could build any specific application and model inferencing construct on. So it supports, it's a performance standardized inference protocol, so it supports different ML runtimes. You can run your Onyx runtimes, you can run your TensorFlow, you can run your PyTorch, and it also supports LLM runtimes, so you can run runtimes like VLLM or Hugging Face accelerators. So essentially, you can have one KServe setup on your cluster, and you're able to support multiple types of model runtimes on top of it. It gives you additional capabilities, like it gives you serverless construct where you can scale down to 0 for your model inferencing. And it also provides ability to do pre and post processing on those model inferencing which you are trying to do on top of KServe. It's kind of built on top of the basic infrastructure layers which most of the organizations have who are using Kubernetes. So on top of Kubernetes, it uses Knative and Istio to act as that serverless plane. And then on top of that, KServe sits as a predictive and generative model inference platform. And if history of KServe is, if you think of it, it was part of Kubeflow, which is the MLOps platform on top of Kubernetes, and it was kind of split out of, and it used to be called KServing back then. It got split out of Kubeflow and KServing into its own project called as KServe, which is kind of supported by community now as an independent serving capability. So to give an idea of like how this works from inferencing perspective, and the whole goal is to make it much more easy and simple for platform engineers to make that useful for dev teams as well as data science teams to consume it. So you can look at it over here. Let me see where's my, yeah. So over here you have the definition of the cluster serving runtime, where you define what are the different kinds of runtimes you're making available. These are the different ML runtimes, machine learning runtimes. So you could, this one is for sklearn server, which is like scikit, and then you could have like other runtime defined on your cluster for like, say, ML server, PyTorch, VLLM. So you can define those runtime servers, and you can say that what kind of supported format that runtime supports. And then for the user who are trying to inference or create or deploy a model and inference from that is where you specify your inference service and you provide your model format, and then you provide where your model sits. The storage URI supports different types of storages. It supports S3 or object storage. You can pull it from a file system. You can also pull it from container registry, or you can pull it from like Hugging Face repository. So storage URI supports different ways of pulling the models from. And then you essentially, you can specify what runtime to use, or if the auto select is true over there in your runtime configuration, then you can just, based on model format, it will automatically choose that runtime for that model. So for me to inference my model, which I've built, say, for example, a scikit model, I just have to deploy this YAML file, and I'll get an inference endpoint. And I would be able to now consume that endpoint and call my APIs on top of it to inference from it. So the goal of KServe is it makes it much more simpler to kind of stitch together all the things which is needed to inference that model, from either whether it's the under hood ML runtime, as well as whatever model storage you need, and how do you plug it together and bring it up front as a consumable endpoint. Now, so on the LLM side, KServe LLM runtime supports essentially two different serving runtimes. One is Hugging Face LLM service serving runtime, and the other one is KServe LLM serving runtime. Within the Hugging Face server runtime, it implements two backends, which is the Hugging Face Accelerator backend, as well as it implements the VLLM backend. Have any of you have heard of VLLM runtime from models perspective? So VLLM is pretty widely used at this point in the industry for ML runtime. It's kind of used by some of the largest inferencing companies out there in the AI space. So it's pretty powerful. It has pretty solid backing from community perspective behind it as well. And most of the projects which are trying to abstract and make inferencing simple are somehow under the hood using VLLM to make it happen. So KServe does that too. KServe under the hood uses VLLM. Out of the box, it uses VLLM, and you can choose to use Hugging Face Accelerator as well if you want to. Out of the box, kind of builds out some of the ML tasks, so you don't even have to kind of build it yourself. You can get the LLM model, and you can have some of these tasks already available to you, like text classification, token classification, generation. You can extend that to build your own other task capabilities based on the model which you have and it supports. But some of the common tasks on some of these LLM models are out of the box supported by the Hugging Face LLM runtime. And then the other one is the KServe LLM serving runtime, but it's essentially which kind of gives you the ability to run your KServe ML runtime as an LLM runtime on KServe itself. So what I'll do now is I'll quickly show an example of using the Hugging Face LLM serving runtime and how it works on KServe. Let's see if I can bring this up here. Yeah, I should have not extended the desktop. Now I cannot see where it is. There you go. All right, so one other thing I'll bring over there is the code itself. Say again? Yeah, let's do that. That's easier. Instead of going back and forth, mirror. Come back. There you go. All right, so this is my Hugging Face runtime. I am using Google T5 Small just for this demo, so that it does not take a lot of time to pull it down and run it. I'm using backend as my backend is Hugging Face, and I'm specifying my model format. Since I'm pulling this from Hugging Face, I'm specifying my token, so I've deployed a secret where my Hugging Face token is. And I'm specifying the resource requirements. I'm specifying that I want 3 CPU, 6G memory, and I'm specifying mixed slice, which is a 10G mixed slice out of 80G A100 machine. And that's it. So this is all I need to get this particular large language model up and running and inferencing on KServe. So I can go here and see if this is big enough. So when I apply this, let me pull up, it spins up an inference service called as Google T5. And it will start spinning up the inference predictor pod for me, which is for this particular model. And if I go into the logs for this, their work. Yeah. So if you look at the payload, it loaded tokenizer over here, and then it loaded the Hugging Face model from path Google T5 T-small. So it actually went out to the Hugging Face and pulled this model. This is a small model. I think it's about maybe 200 MB or 300 MB model. It's a T5 small model. So it took about about 2 seconds for it to pull 200 MB model. And then registered the model and started up the server. So now I can consume this. I will copy my port forward. Which one is that? This one. And go to my Postman. So I'm just calling this T5 model. I'm giving it a prompt, and I'm not streaming over here so that I can see the entire output here. And essentially, so this is one of the things. KServe automatically serves some of those OpenAI endpoints or standard API OpenAI endpoints for the model which you are trying to serve over here. So I can just directly go to that endpoint and call this and get a response back. And I should be able to see in the logs as well what happened here. But essentially now, even if I'm experimenting with things like OpenAI, I can actually go change nothing on my code and just go to point my inference server, and the same thing would work over here. So for example, if you're doing chat completion, text completion, summarization, any of these tasks on, say, OpenAI-based APIs, you can deploy your own model now, whether it's T5, whether it's Llama models, Mistral models, and just point your code to that. Now, sure, it won't be exactly the same as using the OpenAI from the response perspective. It's based on each language LLM model's capability. But essentially, you are able to move to different model without having to change any code, just pointing your endpoint to now a KServe deployed model inference endpoint. So that's how simple it is to deploy a model and get it up and running. Now going back to my slides. Will it work? Yeah. That was a demo. So quickly on, like, we just saw that it pulled the models from Hugging Face and it served it. That was a pretty small model, 200 MB approximately, so it took 2 seconds. But think of the large models, like if you want to deploy a 400B parameters, Llama 3.1 models, it's like 763 GB to pull down. Llama 3.1 is 140 GB to pull down. Some of these large language models kind of range between 2 GB to 80 GB models in general, which are the open source models available. So when you're pulling down and you're running these as a model inference service and you have to scale, for an example, you're scaling down to 0 so that you don't consume your GPUs just because nobody's using it, and you scale up, or you scale out when you have more transactions, the time for that service to stand up and serve, it's going to be as long as it takes to download those things, right? So there are different ways to solve for that. You can have your nodes which has all these models already there somehow, and then kind of pre-treat those nodes which you have on your clusters, and then so that it doesn't have to download all the way from Hugging Face. Or one of the things which you can do is, which KServe provides, is using OCI container image of that model as your model to load. So essentially, it uses the constructs which is already built out in Kubernetes to pull down a container image and run it and cache it. So when a new instance of a pod comes up, it's going to use the cache which is already there on the node to serve that model. On a new node, it might still have required to pull it down, but once it's pulled down in one node, in that node, it can scale up and scale down pretty quickly and pretty fast, because now it will be kind of using that model from locally in the disk of the container, which is kind of mounted in the container itself. So it doesn't have to go to Hugging Face. It doesn't have to go to external storage. It can pull it down from there. So just to quickly tell you about it, it reduces the startup times, as I said, low disk space usage, because you're not kind of saving it in different nodes all the time. It enhances the performance. And it is compatible with KServe infrastructure overall to make it happen. So I'll quickly do a deployment for that to give you a demo of it. Let's see, where did my, there you go. Did it go? I went on extension again for some reason. So in this case, I'll deploy this Modelcar and get my pods. If you'll see, in this one, there is an additional container, and that additional container is essentially a container which is serving that model from an OCI image. So if I see the logs of this, in this one, it took about, I would say, 800 millisecond or about a second to load. The difference is small because it's a very small model I was demoing it on, T5 small, 200 MB. But it took about 2 seconds to 2.5 seconds to pull it from Hugging Face, versus it took about less than a second to get it up and running through the mounted OCI image on the node. So that's the primary difference between Modelcar OCI. And to quickly show you what it looks like from deployment perspective, you specify your storage URI as your OCI image, and essentially to build it out, you just pushing your model data folder into the image and pushing that image to your container registry, and that's it. That's all is needed to get it up and running, and then you can use that inference. So that's the kind of the overall talk track. Any questions on any of these aspects?
For KServe, do you also need the GPU? Like, is the GPU mandatory?
It is not. So you can actually serve a lot of these smaller models just GPU. You don't need GPUs to serving those. Like, for example, I can actually do T5 small on a CPU because it's not that big, and it can still give me the performance I need. And some of the things which VLM runtime provides is the ability to do things just on CPU. And even in large language models where it needs GPU, you can share GPU and CPU together and offload some of that. For example, if you are running a very large model which requires 4 GPUs, you can actually do 3 on GPU and share another one through CPU and do CPU offloading. But it's not necessary that you need GPU to run KServe.
But in real life scenario, like for large customers where there's like huge number of users, simultaneous users,
yeah,
have you seen in real life GPUs being used by default?
For larger models. Smaller models, you can still serve on CPU. You would need more CPUs to support it, but smaller models can still be served through CPU. But it does not, like for example, 1B parameter model is still very small, and you would be able to serve through just CPUs and get the performance. Again, test. You would have to test, performance test it, and see if you need how much scale you need to make it happen. But you can still do it with CPU.
One more question is, initially you spoke about from Kubeflow, the KServe separated. So
Right.
can you know what are the difference between, and then what is the use case for even Kubeflow?
Yeah, so Kubeflow is the overall MLOps platform. So you can, if you think the main difference is Kubeflow is training and fine tuning, KServe is inferencing, right? So when you want to train the models, Kubeflow has the built-in kind of abstraction of like how do you start a job of training, inject your training data to it. Do you have a base model you want to start off of? So it gives you that MLOps capability of training and fine-tuning with Kubeflow. And when you want to inference it, run it in production, your fine-tuned model, or even your base LLM models, that's where the KServe comes into the play, and you inference it. And the reason, I think one of the primary reasons was the industry driving it to an extent where a lot of data engineers were already using some other tools to do training. Like for example, they were already using Databricks, SageMaker, and all of the things. But when it came down to serving or inferencing and deploying these models in production, that's where the gap was. So I think that split happened to make KServe independent to be able to be used as just an inferencing engine.
If you want to have RAG, then is it enough to take RAG and integrate with KServe? There's nothing to be done with Kubeflow, right?
No. So essentially, yeah. So essentially, if you want to do RAG, you get your vector database from somewhere, whether you take it from cloud or you deploy your own, or you can deploy your own vector database as container. And then you have KServe for model inferencing. So you run your LLMs over here, and you can build your RAG application out of it. Your app. As you saw, that OpenAI API standards were already available. So your Python or Go app, which you're writing to do your RAG application, can just connect to this endpoint for KServe endpoint for your LLM and your vector database for pushing your embeddings. And you have your RAG application running. So, and KServe is pretty lightweight. I could have shown it to you, but it's like 4 different things it's running. It's running Istio. I mean, you don't even have to run the full Istio. You do run Istio base, you run KServe, and you run Knative, and you have your application, your inferencing up and running. And Istio kind of puts out an ingress endpoint for you, or you can deploy a gateway API to do, DNS-based external gateway endpoint for you.
Anyone else? Last one.
So how would this be good for implementing into edge AI, where you would be using CPUs often anyway to pull it to a local device?
Yes, you could. Yeah, you could use it in edge because if you think of it as, in fact, you could look at scenarios where you are running on edge, say something like K3s or even lighter weight Kubernetes construct, and then you're deploying KServe on top of it, which is not very, it's still lightweight, and run your inferencing through maybe the local registry, or just models pulled into that particular edge device and can serve it from there. So you can pre-warm that edge device, and it doesn't even have to go out of the network to pull anything down. It can just completely serve everything from that edge device. And you can even use things like the NVIDIA edge devices where you just have one GPU on it, or you can even have GPU on those edge devices.
All right, thank you. Applause, please.
Yeah. Thank you.